Imagine looking up at the night sky and knowing that one of those tiny dots of light, many light years away, is home to an alien civilization. Even more thrilling, what if we could detect their presence not by their radio signals or spacecraft, but through the very air they breathe? What if the key to finding extraterrestrial life lies in the peculiar manufactured gases in their atmosphere? Could these telltale signs be our first contact with an advanced civilization? The quest to find extraterrestrial life has captivated humanity for centuries. From ancient myths to modern science fiction, the idea of life beyond Earth has spurred countless imaginations. Today, we stand on the brink of transforming this dream into reality, thanks to groundbreaking research from the University of California, Riverside. This study proposes that artificial greenhouse gases, detectable in the atmospheres of distant planets, could be clear indicators of alien terraforming efforts. Terraforming, the process of modifying a planet to make it habitable, is no longer a mere figment of science fiction. Scientists believe that if an advanced civilization exists, they might use certain gases to warm their planets, making them suitable for life. These gases, detectable even at low concentrations using existing technology like the James Webb Space Telescope or the proposed European Life mission, could be the smoking gun that tells us we are not alone. For us, these gases are bad because we don't want to increase warming, but they'd be good for a civilization that perhaps wanted to forestall an impending ice age or terraform an otherwise uninhabitable planet in their system, as humans have proposed for Mars, said UCR astrobiologist and lead study author Edward Schweiderman. This perspective shift is crucial. What we consider pollutants on Earth could be lifesavers for another civilization facing a planetary freeze. The study zeroes in on 5 specific gases, fluorinated versions of methane, ethane, and propane, along with compounds made of nitrogen and fluorine or sulfur and fluorine. These gases are used on Earth in industrial processes, such as making computer chips. Their presence in another planet's atmosphere would be highly unusual, signaling not natural processes but technological manipulation. One standout example is sulfur hexafluoride, which boasts an astonishing 23,500 times the warming power of carbon dioxide. A small quantity could dramatically alter a planet's climate, warming it sufficiently to support liquid water and, potentially, life. Additionally, these gases are incredibly long-lived, persisting in an atmosphere for up to 50,000 years. This means that once introduced, they wouldn't need frequent replenishment, making them an efficient solution for maintaining a stable, hospitable climate. In the search for techno-signatures, indications of technology-using civilizations, these gases are prime candidates. Unlike chlorofluorocarbons, CFCs, which are also artificial but problematic due to their ozone-depleting properties, fully fluorinated gases are chemically inert and do not break down easily. This makes them more stable and easier to detect over long periods. If another civilization had an oxygen-rich atmosphere, they'd also have an ozone layer they'd want to protect, Schweiderman explained. CFCs, which destroy ozone, would not be practical for long-term terraforming. In contrast, the proposed gases would allow an alien civilization to maintain both their climate and their protective ozone layer. The detectability of these gases hinges on their ability to absorb infrared radiation, creating a distinct infrared signature. Space-based telescopes could potentially pick up this signature, even from planets light years away. Schweiderman noted, with an atmosphere like Earth's, only 1 out of every million molecules could be one of those gases, and it would be potentially detectable. This minute concentration would still be enough to modify the climate, making the planet warmer and more habitable. To test their hypothesis, the researchers simulated a planet in the TRAPPIST-1 system, located about 40 light-years from Earth. This system, with its 7 rocky planets, is one of the most studied exoplanetary systems and a prime target for future observations. By modeling the presence of these gases in the TRAPPIST-1 planet's atmospheres, the researchers demonstrated that their detection is within the realm of possibility with current and forthcoming technology. The European Life mission, for instance, aims to directly image planets using infrared light, offering a more detailed look than the James Webb Space Telescope, which relies on observing planets as they transit in front of their stars. This capability would significantly enhance our chances of spotting the infrared signatures of these exotic gases. Collaboration is key in this groundbreaking research. The study involved experts from the Swiss Federal Institute of Technology Planets, NASA's Goddard Space Flight Center, the Blue Marble Space Institute of Science, and Paris University. This diverse team underscores the global interest and collective effort in search for extraterrestrial intelligence. While the researchers cannot guarantee that we will find the technosignature gases soon, they are optimistic. If these gases exist in the atmospheres of nearby exoplanets, we have the tools to detect them. You wouldn't need extra effort to look for these technosignatures if your telescope is already characterizing the planet for other reasons, Schweiderman noted. The prospect of stumbling upon such a discovery while conducting routine observations is tantalizing. The potential implications of detecting these gases are profound. Not only would it be a monumental scientific achievement, but it would also fundamentally change our understanding of our place in the universe. Edward Schweiderman and his team's work highlight how close we are to possibly making one of the greatest discoveries in human history. Daniel Angerhausen, a collaborator from the Swiss Federal Institute of Technology Planets, expresses excitement about the advancements in technology that have brought us to this point. Our thought experiment shows how powerful our next-generation telescopes will be. We are the first generation in history that has the technology to systematically look for life and intelligence in our galactic neighborhood, he said. The search for alien life has evolved from speculative philosophy to rigorous scientific endeavor. As we continue to refine our techniques and expand our observational capabilities, the day we detect a technosignature in an exoplanet's atmosphere may be just around the corner. Imagine the moment when we confirm that we are not alone, that somewhere out there, another civilization is also looking up at the stars, perhaps wondering if they are alone too. The future of astrobiology and the search for extraterrestrial intelligence is bright. With every advancement in technology and every new discovery, we edge closer to answering one of humanity's oldest and most profound questions. Are we alone in the universe? The answer might just be hidden in the telltale greenhouse gases of a distant alien world.